Anybody else? Or like we
You
can
better
still
start,
continue.
Daniel.
Okay, so we're gonna continue. There's gonna be Q&A at the end, like half an hour or more. So if you can mute yourself, and I'm gonna do a quick 2-minute intro, if you guys okay. And so save your questions until the end, and then during Q&A you can unmute yourself. So for those of you who are first time with us and wonder who we are, Serverless Toronto started 8 years ago as meeting place for function as a service developers. But during COVID, we migrated to online format. And over time, we realized that we could help businesses by working smarter, not by sprinting fast. And we started defining serverless not just as a tech stack, but as a pragmatic mindset, a way to focus on business value. And this broad definition of serverless lets us explore many IT topics. So if you visit our YouTube channel, you will see years of educational content. Much of it is still relevant. And as Gen AI is shaking the ground on the industry, it's hard to sort facts from the noise and to know which skills to build. So let's use a collective intelligence, hive mind, and vote on the topics for upcoming meetups. So I took a screenshot today of a MEAP page. This is Manning Early Access Program. Go there, choose your next teacher, drop it in the chat or DM me on LinkedIn, and your vote matters. So we can help one another. And so as you can see, we are lucky to get Manning publications and knowledge sponsor. Normally, they donate a book at every meetup, but today they're giving away 5 ebooks, and no survey is needed this time. But please rate us on meetup.com so they can promote our events to more nice folks like you. And for those who don't win, Manning is also giving 45% off coupon code for any of their digital products. So enjoy the savings, scan the barcode. And before I pass the mic to our guest, let me explain why this topic. So just getting AI RAG systems right is not easy. And then, like at the end of the last year, everybody started talking about AI agents. And I noticed the confusion in the industry, both for those buying solutions and those building them. And the vendors are not helping either because everybody's selling you their agentic system. So I wanted us to slow down to understand the building blocks, what's under the hood. And I'm not saying you must go do it yourself way, but in this zoo of options for building AI agents, you need to understand the components, the interfaces, and how they work together. So Andre, thank you so much for accepting my invitation. We're honored to have you with us, and floor is yours. Please take it away. That's my intro.
Thank you, Daniel, for the kind introduction. I will share my screen now. That was actually really cool, that first 15 minutes in a meetup of having folks intro themselves. I've actually never seen that before and at such a high success. So kudos to this community and welcome to all the newcomers. I'm also a first-time comer to this meetup. And also a big shout out to the folks who are, doing the courageous thing and dipping into a new field, going from a non-tech field into AI. Andre Karpathy, I think Daniel had mentioned, everyone is basically now a developer. And so welcome to you all, and hopefully you enjoy the presentation and you learn something useful. Okay, can you guys all see my screen? All right.
Yep.
Okay, so yep. So Daniel mentioned I'm going to go through my book, which is going to be published by Manning. It's available now in the Manning Early Access Program, or MEAP for short. It's titled "Build a Multi-Agent System from Scratch." Okay, so real quick, just about me. I'm an AI engineer slash researcher. I am right now at Carlyle, the Carlyle Group, doing some AI stuff, learning some AI stuff applied to the finance domain. I'm not a finance guy, so but I do know how to turn real world problems into AI problems, and then turn these problems into software and product. So that's what I'm having fun doing at Carlisle. Before Carlisle, I've listed here I was at LlamaIndex, but before actually Carlisle, I was at Vector Institute in Toronto, where I was doing some AI research. Contributed to a code base called FedRag, which was accepted into ICML workshop recently. And then before Vector, I was at LlamaIndex for about a year and 4 months as a founding engineer, where I maintained the open source Python library. called LlamaIndex, and that was a ton of fun. I think we were getting still 40 million downloads per month, if not more. And a lot of the learnings that I got from, maintaining that open source library with Logan and Masi, of course, folks who worked with me there, I've applied into this book. And so hopefully, folks again find it useful and learn something from the book. I've got a PhD in probability and stats, so I've gone a permanent head damage. I guess that's what PhD stands for. And yes, I'm a Manning author for Build a Multi-Agent System from Scratch. All right, so for today's agenda, I've got 5 items on the docket here. Um, one thing I should mention is I again like shout out to all the newcomers into this space. I was going to go, take a quick sort of path to through like the fundamentals of an LLM agent, but it sounds like it might be beneficial for me to go a little bit slower in that, if you guys will. So I will go take my time in the building blocks as much as possible, so hopefully all folks here can benefit. So yeah, no, I'll start off with about the book, then I'll get into quick, not so quick primers, talk about what an LLM agent is, what's that in terms of the difference between an agent and an LLM, working with tools and LLMs and tool calling, talk about the LLM agent class that we build in the book, then we'll get into MCP tools. Then we'll get into skills, which was a chapter that was not originally planned in the book, but this space is crazy and it moves super fast, so you need to be adaptable. And so we added skills just in the last minute here. And then lastly, I'll talk a bit about A2A, building multi-agent systems with that protocol. All right, let's just jump right into it. Oh, and by the way, this is a Jupyter notebook. I'm running this Jupyter notebook on my run on a RunPod that's got like tons of um, gigs of RAM so that I can run a QN480B model. And this demo notebook will be available. Actually, it is available on the GitHub already. Also, there are instructions for you if you want to spin up your own RunPod and provision the same template that I'm using so that you can run this repeatedly yourself on your own time. All right, so about the book. So from scratch, essentially, when I was talking to the editors about potentially doing this book, when we were talking about LLM agents from scratch, the only thing I could think of from scratch was like, okay, we got to build the entire framework. You got to build the tool calling, you got to build the LLMs, you got to build the tools, um, and the LLM agent in the processing loop, right? So this is the philosophy of the book. We will build a framework called LLM agents from scratch. You can consider it if you like as an alternative to the LangChains, the LlamaIndex, to CrewAI, with the caveat that it's not meant for production. We are building this framework, optimizing for education. Should you want to get punched in the face and use this in production, that's up to you. But we are, making design decisions to optimize for education here. So we'll cover tools, LLMs, implement our own processing loop, create implementations, sorry, integrations for MCP, support the skills standard. The next chapter after skills will be memory, then human in the loop, and then finally we'll close it off with A2A. As I said, it's available now in MEAP. So the first 5 chapters are available. Chapter 6 will be available very soon. I think you'll see actually this here better. So chapter 6 is coming soon. It's on skills. Chapter 5, 4, 3, 2 are all available. Of course, chapter 1 is an intro, but this is the roadmap for how we're going to develop our LLM agents framework. So you've got your tools you start with, your LLM, then you build the LLM agent class. You implement what's called the loop or the processing loop. This is where the agent actually performs tasks autonomously on behalf of the users. And then we extend the capabilities of our LLM agent in part two, building out MCP tools. And then chapter 6 again is extending the capabilities of LLM agents once again with skills and then human in the loop and memory. I did a thing of swapping the order here, so my bad. And then finally, we'll close it off in part 3 to connect multiple agents through what's called the A2A protocol. Okay, and I left here links to the book website, Moss from Scratch. If you go here, it's there. You've got more details about the book, the chapter notebooks, and also, some more examples. There will be, in addition to the book content, more content that comes up in that web page or in the repo for, just more deeper examples in the book. So they'll point to when you're reading it so that, keeping in mind space for the book, I'll just point to the GitHub repo of like, you should read these examples. There's also a thing called capstones. If you bought the book originally, there was a different version of this roadmap, which included capstone projects. To me, not only is it enough to just, build something from scratch to learn, but we would like to deepen our learnings by applying what we learned for actual like applications. So capstone projects are meant to take what we learned in terms of what we built and apply them to real-ish applications and talk about other things like evaluation and whatnot. Okay, and the GitHub repo is there if you want to check it out. All right, let's get right into it. So, section one, quick, not so quick primers. What is an LLM agent? I've heard folks, talking about they love Claude Code. And I guess the question I would love to ask, if I'm allowed to ask questions, Daniel, um, is, what is Claude Code? What is Claude Code to you guys?
Just an agent plus a RAG.
Sorry, can you repeat that? I didn't get it.
It's just an LLM with a RAG.
It's a harness for the LLM.
Cool. I mean, I think I can't dock points. I think those are correct. I might add some nuance now according to the terminology that we use in the book. But yeah, let me go through that. Thank you for your answers. So what is an LLM agent and how do we define it in the book? In the book, we say an LLM agent is a system. It is comprised of an LLM, right? As well as tools, and it acts on behalf of the users to perform tasks autonomously. Okay. And so when going back to Claude Code, to me, what Claude Code is it's got a backbone LLM. That backbone LLM is likely Opus 4.6, Sonnet 4.6, and it's got access to tools. So the tools, I think someone mentioned RAG. Um, I think that's definitely a component of it potentially. I think it's got file system tools like bash tools, read, grep, glob. So it's an agent that sits on top of a file system with those type of tools to be able to interact with files in that file system. Okay, so yes, in this book, we'll learn how to build all these individual components here, the backbone LLM, the tools, and the LLM agent that will actually perform the task that is specified by the user. All right, so continuing on, so tools and base tool. So um, in this book, what we do again from the ground up or from scratch, what we need to do is define what tools are, right? So LLM agents use tools, but what is a tool? And how do LLMs use it? Like LLMs are, what are they? They're deep learning models that do what? Does anyone, I think, does that someone knows what, could someone answer what an LLM predicts?
Yeah,
Predict
so
the next token.
an LLM predicts the next most likely sequence of words or tokens based on the input that you give it, which are the previous words or n number of words.
That's right. So it is a generative model that predicts the next token or word from a given input sequence. And I'm talking specifically like LLMs here, not VLMs or anything like that. So they predict the next word more simply, and they usually operate on a finite vocabulary, right? So finite set of words, they figure out the probability distribution of all these words in that, the finite vocabulary. And then there's some sort of sampling that happens to, produce the one of the most likely next words to appear after a given input. And so when you think about that and LLMs as generating text, and then you think about tool calling, it's like, well, that doesn't, how does that compute, right? How does a text generator perform tool calls. And this is a little bit getting ahead of ourselves. We'll complete the discussion when we talk about LLMs. But basically, what we need to do is we need to get the LLM, elicit the LLM to generate text that makes it say like, I want to use this tool, right, in words. And then it tells you what the arguments are for that tool, because that tool is likely a function that you would like to supply, that the LLM would like to supply, and that we call a tool call request. So basically, again, what I'm saying is LLMs are text generators. Tool calling involves eliciting the LLM to generate text that formulates a tool call request in text. I see your hands up. Go ahead.
Hi, can you hear me?
Yep.
Awesome. Sometimes I see things like there are types of agents like planning agents, and sometimes there are React agents. What are they? What are the different types of agents, and what's the difference?
Yeah, that's a great question. I think planning agents are essentially do, what the name suggests. They come up with in words, maybe using some tools and outputs of tools to come up with a plan to execute on a task. I don't think there's any other magic behind that. It's like it comes up with a plan. And in the book, I also say that one of the prerequisite capabilities of the LLM, when you're deciding an LLM to use for your LLM agent, there are two prerequisites, at least. There's planning and also tool calling, right? Tool calling is an ability that is trained usually after pre-training, um, to give the LLM the ability to be like, okay, this is how you call a tool. I now know how to generate a tool call request according to that structure, right? I digress. So hopefully that answers your first question. The second question, which was what? Sorry again.
Second was about React.
Oh, React. React is an agent processing loop. And so we actually implement in this book our own, but React is another, just like a processing loop. And a processing loop defines essentially the sub-steps in which the agent will take in order to complete a task. So React is like, I feel like it's think, act, observe kind of thing, and then think, act, observe, right? And you keep going through that cycle until the task completes. So we do something similar, but we have a different definition of the think, act, observe philosophy. Okay, just continuing on here with the quick primers. So I mentioned before LLMs are text generators, where we have to get them to elicit text, right, in order to represent a tool call request. And so what we've done in the book and in the framework, we show you how to build out a tool and what things you need to provide, such as the parameters of the tool. And you do that through a JSON schema, parameters JSON schema. And this is essentially a description of how to call the tool. You pass that to the LLM, it's text, it returns back some data that conforms to this JSON schema, i.e. the tool call request, that now can be used to actually execute the tool with. Hopefully that makes sense. And if not, I encourage hopefully folks to buy the book. Okay. I can go straight to some demos here. So basically, these are the data structures that you'll build. I'll go through this real quick. So we'll build out the tool call data structure. It's got a tool name, right? So every tool has a name. Then there's also arguments that are come with the tool. So in this fictitious almost tool, which is a web search tool, one argument is query. And so the human or the LLM, likely the LLM or LLM agent, needs to provide a query. So croissant bakeries in New York City and their prices, this is what a tool call would be. And then tool call result is just the opposite end of the tool execution. So imagine the LLM produced this. We would then provide it to our tool. We would execute the tool with that tool call, and then you might get a result that looks something like this, right? So we go through all of that in the book. I won't belabor that much more. This thing here is also another thing that we go through in the book, which is how to build your own tool. So we defined this base tool class, which provides a standard interface for how you define tools that LLMs and LLM agents can work with. And so if you conform to this interface, which requires a name, a description, again, the parameters, and you provide the information of the parameters in a JSON, which then gets, serialized to the string eventually to the LLM. You pass, you define these three attributes, and then you define your actual execution. So how do you actually execute the tool? The logic is contained here. All that, again, you go through the book, just again trying to show it's very much bottoms up. You define this interface. We show how to work with this interface in the book, and then you've got your tool, and then you can pass in. You can create a tool call. You can pass in a tool call to your tool, and then you can see the result. Now that was us doing it, right? I'll skip through this. But what about an LLM actually doing it? So the first component to an LLM agent obviously is tools, as I mentioned. The second component, 1A, 1B kind of thing is the LLM. And so obviously there are a ton of LLM providers. There's like closed source options in Anthropic, OpenAI, Cohere, for those folks from Canada. And they all have their own different interfaces and SDKs and whatnot. And so what we do in the framework is we build a quick standard interface as well, similar to tools, that will allow us to define the interaction modes with LLMs that an agent would have, or even humans. And so similar to base tool, we define this base LLM. We've got the traditional complete method here, which completes the sentence, predicting the next tokens. We've got the chat interface, which is, I still think, supported by OpenAI, but I think they moved on to maybe something called the Responses API. But this is representing a chat interaction between a user and assistant, so messages kind of swapping between assistants and the AI and the user, and then sometimes interwoven in there are some tool calls. We go through again this in the book, so you learn in the book how to define an LLM interface and importantly implement the interactions that are required for working with LLM agents. One thing I want to call out is that we build this book using Ollama. And so in the book, we not only do we define a standard interface called base LLM, we also will work together to create an integration to Ollama called Ollama LLM. And so this allows us to use any open source model that you can have running on your machine. As I mentioned at the start of this talk, I am running this notebook on RunPod, and I've got very soon you'll see 480B Q13 coder running. And so yes, so let's just see this in action. So if we have import our Ollama LLM and we specify the model here, okay, then we can get the LLM to tell us a joke. So LLM.complete, tell me a joke. Sometimes if I'm idle for a bit, then RunPod will shut down my Ollama service. So it needs a little bit of startup. I think it's actually working now. Okay. Hold on. Okay. Why I think it's the same joke. Maybe it's cached. Why don't scientists trust atoms? Because they make up everything. Okay, so that is the complete interaction. In the book, you learn how to build the complete interaction. Another useful one is called the structured output interaction, where you're asking the LLM to provide a response in a structured manner, right? So like a JSON, for example. In the book, you learn how to do this with something called pedantic, which is a data class type of library. Yes, I see your hand, Ray. Go ahead.
Oh, I'm not sure if we are allowed to ask during the presentation or save it for later. All right, I'll just ask.
Yeah, you can ask now,
Oh.
but it's easier to watch on YouTube afterwards. So he has
Okay.
unit of work. So save your question, note it down, and we'll go at the end.
Okay. I'll just put it in the chat and we can discuss later.
Okay. Sorry.
Okay. All good. I forgot that we're running on YouTube too, Daniel.
Not live. In 2 days, I will
Oh, in
post
2 days.
this.
Okay. Got it. Okay, so let's just see this real quick. And you can see here, chapter 3, example 3, chapter 3, example 4. So every chapter in the book has its own dedicated notebook. And so I'm pulling in this talk, I'm pulling from those examples, just as an FYI. So if we see this demo real quick for the structured output, what you'll see is it returns a joke. So the LLM was able to produce text in the desired output, which is in this format here. And the subject is physics. Why did the photon check into a hotel? Because it was traveling light. Um, okay, that was um, chapters 2 and 3 essentially in like 5-10 minutes. So building tools and building LLMs, interfaces, all of that required infrastructure to then be able to build LLM agents. Oh, sorry. I went ahead. There is one more part in chapter 3, which is tool calling with LLMs. Does anyone know how LLMs do tool calling? If not, it's okay. I can go through it. So basically, in the book, the way that we illustrate it, so an LLM who knows if it knows about certain tools, the way that we get it to perform a tool call is you give it some query. It then looks at all the tools that it has available in its context. It then decides, oh, I need to use this tool, right? Once it decides that it needs to use that tool, it will look at the parameters JSON schema to understand how can I call this tool? What arguments do I need to supply? And so that's just text. So it will come back and give to the users, like, I want to use this tool, and I want you to use these arguments for that tool execution. And that again comes back in text. So once that happens, then the tool execution actually happens, on the user side, and we will compute the tool execution. And then what we need to do is take the tool call result and pass it back to the LLM for response and synthesis. So that's essentially how, like, the LLM is not performing the tool call. It's saying, I need this tool performed with these arguments. You perform the tool execution, and then you take the result and you pass it back to the LLM and say, here's your tool result. And then it, synthesizes that and generates the next response. Okay. Hopefully that makes sense. Again, as you probably guessed it, you implement all that in the book from scratch as well. Okay, and here's a quick demo of it. This is just building the Hailstone step function tool. The Hailstone is a geeky. I think I heard some folks talking about hanging out with very geeky people. I am definitely a geeky person. This is something I learned from my math days. It's called the collapse conjecture, is another name for it. I think it's one of those problems that is still $1 million if you solve it. So it's unsolved. I think Paul Erdos, I think he said of this problem, it's one of those unsolved problems that is completely useless. So if you want to bang your head around a completely useless problem and try to win $1 million, this would be the one. Okay, so basically what it is you start with a number. If it's even, you divide it by 2. If it's odd, you multiply it by 3 and you add 1. You repeat this sequence, and basically what it's saying is that you will always get down, no matter what number you start at, you'll always get down to the number 1. That's the collapse conjecture. So this function is just performing one step of that sequence. So if you can see here, if x is even, divided by 2. If it's odd, this is the else, right? Multiply by 3 and add 1. So we've got some convenient interfaces in again the book's framework that we will build together. This allows you to take a function, a Python function, and turn it into a tool that you can use with an LLM, right? And the way that you get an LLM to perform a tool call within our framework, and like many of other frameworks, is through the chat interaction. So we'll do llm.chat, we'll give it some query, right? What is the result of taking the next step of the hailstone sequence on number 3? And this, I'm like trying to elicit the LLM to be like, hey, I need to use this tool call. I mean, this tool. So if I do this, hopefully what you see is the response, which is, okay, the tool call is saying, I need to perform a tool call. I want to use the hailstone step function, and the argument I want to apply to that tool is 3. So this is essentially what I mean about getting the LLM to elicit in text a tool call request. Then we perform that tool call request by executing, passing that tool call into the hailstone tool, and we get the result. And as I mentioned, as soon as you have the result, you got to send it back to the LLM, which is what we do with this method here, continue chat with tool results. This is not probably something you would find in a production grade framework, right? So this is where the things are sort of deviating. This is probably just tucked away in chat. But I wanted to make this explicit to the reader that this is how the tool calling is happening. Again, the LLM selects a tool, it then provides the arguments for that tool. We perform the tool execution. We then continue the chat with the tool results that we get. And if we do that, then it says, okay, your result is 10. Not super interesting. Obviously, there are way more interesting applications of tool calling, which I'm sure you guys are all using now. If you're vibe coding, or using Claude Code, they're using a lot more elaborate tools of interest. Okay. Looking at the time, I'll go through. What time do we have, Daniel, for the presentation?
Oh, you can go like an hour or more, so I believe half an hour for questions.
Okay.
But like I can stay longer if you want. It's
Okay.
going to be recorded.
Okay, thank you. Okay, so we've covered now LLMs, tools. Chapter 4 now would be let's build an LLM agent. This will be the first time we'll build an LLM agent from scratch. Remember, our earlier definition is an LLM agent is at its core a backbone LLM and a set of tools, and it is a system that performs tasks on behalf of its users with the LLM as well as the tools. There's more, I sort of view that as like the canonical definition, and then we add sort of layers on top to make the LLM agent even more powerful. Okay, so when we get to chapter 4, let's, based on that definition, let's create this LLM agent class, right? And so we'll develop that together in our framework. And, some attributes for that LLM agent will be, of course, the backbone LLM, the tools that you want it to use, and then the special, method that does a lot of the heavy lifting, which is the run method. So the run method, what it will do is it will take the task that the user provides and it will spin up a processing loop and it will perform that task within the processing loop, making use of the backbone LLM in terms of its reasoning abilities and its tool calling abilities, as well as the actual tools that it has at its disposal. Okay, and someone asked a question of React, and I answered that React is one way of implementing a processing loop. In the book, I do make mention of React, but again, we implement our own processing loop ourselves. And this is actually what I'm getting into now. So this one is a bit busy, this picture, but just bear with me for a second. So basically, what happens when you've got an LLM agent? Sorry, I'm trying to zoom in, and here's the run method, right? And the task, this is the user input. So it's like, perform the hailstone sequence of number 10, right? That might be the task. That's the instruction. We pass this to the run method. And this is a bit of an implementation detail, to be quite honest. So let me just skip that for now. But basically what happens is that you'll get into these, gray shadowed areas. And these represent discrete steps that the agent is going to take to complete the task. And again, in React, it's this sort of thought, act, observe, thought, act, observe. In the framework that we build in the book, it's, get the next step, run the step. Get the next step, run the step. Get the next step, run the step. You keep doing that until the agent calls guess, oh, I'm actually done. And so the next step is actually just to complete the task and submit the result. Hopefully that's clear for folks. In terms of what else is going on in this picture, the task handler is an async IO future. So it's a primitive that allows us to set the result later on. So like sort of like a promise, if you will. Um, and what this affords us is concurrency. So we'll see later, very soon, that we can spin up an LLM agent and then we can run like 10 concurrent tasks, and it will each have its own dedicated task handler for us. And that's also part of, yes, we implement that together, but in the capstone chapter, sorry, that's free again on the website, you'll see how it is that we do that. And you would want to do this replication because you would want to, evaluate your performance, and you don't want to evaluate on just one uh, instantiation. Okay, so let's see this in some action. Um, so there's some utilities here. This one, like whenever there's utilities in the book, I don't really go through how to do that, like walking you through the code. In the book, I go very slowly in terms of like, we are doing this, and this is a design decision, and here's the code listing, and here's why we do this. For most, if not all of the core bits of the code in this framework. But for utilities, things like this, I just say refer to the GitHub repo if you want to see the code. But what this would allow us to do is it will just allow us to see where the agent is at in terms of its execution. Okay, so what we're going to try and get the agent to do is actually perform the hailstone sequence. So starting with number, I think we'll start with number 10 or something like that. Remember what the sequence does is you look at the number. If it's even, divide by 2. If it's odd, multiply by 3 and add 1. And you keep going through that until you hit 1. Right? So basically, the LLM agent needs to know to make repeated tool calls of this tool based on what the current value of that number is, right? One thing I did have to do is because hailstone sequence is well known, collapse conjecture is well known, and so like, very good, even open source LLMs are pre-trained on large corpora. So they've already know the hailstone sequence. So what will happen is if I don't make the modification, which I'll tell you very soon, without the modification, it will just avoid using the tool and it will go straight to just like, I know what this is. I'm not going to go through the tool call. I'm just going to give you it's 10, 5, 16, 4, 2, 1 or something like that, right? And so what I did in order to, figure out how to get this to use the tool is I am changing the hailstone to just saying next number. So it no longer knows that this is the hailstone sequence. It just is a function that says there's some magic that will, boop, 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 generate the next number for you in the sequence. And that's all you need to know. Keep generating until you hit 1. Okay, so that's basically what I'm getting this agent to do. Let's see that in action. Again, QN3 coder for ADB. Let's see it. Here's the instruction template. So it's a string. There's some rules. By the way, if you haven't done this before, I definitely recommend using Claude or GPT to create your prompts for you. They're very good at creating prompts for their cousins or competitors. So this is how I create prompts for the book as well as for work. Okay, so let's see. We actually are starting at number 6. We're now saying this is the task, right? And then we're saying LLM agent run this task, and I'm saying for maximum steps. So if I go back to this here, this is step 1, step 2, step 3, 4, 5, right? I'm putting a maximum there because in some tasks, you may know this in practice that like, that task shouldn't exceed maybe 20 steps, right? So you might put a maximum on that. But really good closed source models, I don't think I've ever actually had to specify something like that. And maybe I don't even recall if these frameworks even add that anymore. But in my book, we do build it in that way. And so you are able to specify the maximum number of steps. And let's just see what's happening here. So you can see that the agent is going through and performing this task. So it's executing the tool call next number, successful tool call, which is 3. So it started from 6, it went down to 3. Great. Then the next tool call, great. I made the next tool call was 10. That's right. Then 5. That's right. 16, 8, 4, 2, 1. If you're really geeky, as soon as it hits any power of 2, you've converged to the sequence. So the proof, if you want a hint, I don't know if this is a hint, to prove this, if you can prove that this sequence goes to any power of 2 eventually, then you've proved effectively that it will go down to 1 at some point. Okay, so enough of that nerdy jargon. This task is completed. It says I've received the result from the 8th tool call. The sequence is now complete, 6, 3, 10, 5, 16, 8, 4, 2, 1. So it did it successfully, which is great. The other thing that we want to do when we are assessing the LLM agent's ability to perform tasks, not only are we looking at the final output, right? We want to make sure that the final output is correct according to, whatever that correct means for that task. But also the way in which it got there, right? So was it efficient in its tool calling? Did it miss, for example, in here, what if it just did made the same tool call over and over again or a couple times before it realized, oh, you know what? I'm already at 8. I made this tool call. Weaker open source models typically do that. So you still do want to measure not only just the final output, but also how well or what was the reasoning trace of your LLM agent. And we go through an example in the book, in the first capstone of, doing repeated applications and looking at not only the sample average of success for the task, but also like an LLM as a judge, looking at the trajectories, which are the rollouts. Let me just print this one. So this is the trajectory. This is the rollout that the LLM agent took in order to perform its task, right? So it is also important to analyze this. Again, in the capstone example, we'll get an LLM as a judge to read these rollouts and make some sort of judgment on them. For the capstone problem, it's not the hailstone sequence. It's also it's another mathy one. It's estimating pi using Monte Carlo simulation. But yeah, if you're interested, please do check that out. And quickly, I mentioned this, one benefit of implementing the handler as an async IO feature is we get concurrency. So like you can see here, we can run the same LLM agent. This is now task A, task B, starting with the number 3. This is number 7. And we can get it to run these concurrently here. And so if I'm running that, we won't wait for this. But now we've got 2 tasks running at the same time. And it's being efficient in terms of collaborating in the async IO event loop. Okay, that was chapters 1 through 4, plus a little bit about the capstone problem that is up for free on the book's website. And again, it will allow you to take what we learned and built from chapters 2 to 4, which is the tools, the LLMs, the LLM agent, and apply them to a real-ish kind of problem that will let you to learn how to evaluate an LLM agent. Again, not only on the outputs, but also on the trajectories, which are things we still do very much in practice, right? I think we're still okay for time, right? So perfect. Thanks, Daniel. Coming up, we will go over chapter 5, which was recently released on MCP tools. And then again, we will get into the new chapter, which is almost done on agent skills. And then we'll close off with A2A discussion. So this part gets us into essentially where we've built an LLM agent, like the bare bones, tool calling, LLMs, and the processing loop. Now we're looking at extending the capabilities of our LLM agent. Okay, so the first way that we're going to do that is through MCP. MCP stands for Model Context Protocol. Essentially, it is a standard way of creating and sharing tools as well as other primitives such as prompt templates and data. But tools are predominantly like the most widely used MCP primitive. So in the book, we focus most only on tools. It might be a bonus material that we support data and prompt templates, but MCP tools are what we support for now. So we'll talk about the MCP ecosystem, and then we'll talk about how it is that we actually build the integrations and the infrastructure required to support MCP in our framework, which will allow us to tap into all the available MCP tools that third-party companies and individuals build for us. And so these are all the things that we will build together, and I'll touch on real quickly. Okay, so the MCP ecosystem. So as I mentioned, MCP defines a standard for creating tools that we can share amongst each other, right? And it resulted basically in a large ecosystem of tools. Yeah, that you can extend your agentic applications with. So on one side, you've got your suppliers. They build MCP tools. We're going to go through an example of one supplier, which is GitHub, which makes, their GitHub tools available. One supplier that I use often at work is called Linear. Linear is similar to Jira. If you use Jira, it's a project management tool. And so I'll use Linear MCP to create tickets, write project documentations, and push it up to Linear for my co-developers to look at and work with. So that's one side of the ecosystem. The other side of the ecosystem, of course, are our agent applications. And so our framework that we're building together is one of the consumers. What we need to do is we need to build out, again, the infrastructure required to be able to leverage these tools. Hopefully that makes sense. It's a standard. If you define tools according to that standard, if you define the support in order to make use of these tools, which is defined in a standard way, then you can tap into this rich ecosystem. That's the gist of MCP. Of course, there's a lot more that goes into it, but in chapter 5, you go through, again, from scratch, building it out completely. And just to give you a quick teaser on it, here is the MCP architecture. So on one side is the MCP server, right? So this is where MCP tools are hosted, basically, and the agent is making a request to these MCP servers to perform tool calls. And so these tool executions are happening on an external system. And the results are being sent back to the AI applications, in which, of course, our case is our LLM agent. So you've got MCP servers, MCP clients interact with these servers, right? And then MCP hosts are things that can spin up the MCP clients. So with this terminology, wrapping it into our book and our framework, MCP hosts are essentially anything that uses our framework. So our framework is an MCP host. And there is one thing here that you'll see soon. It's an abstraction called MCP tool provider, which will has the ability to spin up MCP clients and maintain those clients in order to interact with the servers. But yeah, that's the MCP architecture. I know it might be a mouthful, especially to those who are first getting acclimated to MCP, but the biggest takeaway is, it's a standard that defines a way to build tools and interact with those tools that are being executed on an external system. If you get that, then I think that's a big win.
So, Val,
Yeah.
I just have one quick question, like if I can.
Yeah.
So, the MCP server and client, so do we have to adhere to those strict architecture that you just showed, or can we make any server? Suppose, say, I have a Python service that can include multiple functions and then expose those functions as first API endpoints and can still treat that as an MCP server or a service, and then those APIs can consumed as tools provided by MCP server.
Yeah, there's actually a specific way to do it. So like MCP servers, there's two formats of it. There's like the streamable.
Okay.
There's this HTTP streamable version, which will get kind of close to your fast API. There is still like a certain way for you to define a tool and define that server. But like if you're going from fast API
Okay.
to building that, it's not too difficult, to be honest. And then there's the standard IO, which happens is an external system, but it's also running on your local machine, right? So like, and this is an example that we'll run through here, to be honest.
Okay,
Does that
so
answer
so
your
we
question?
have to follow that protocol
Yeah,
in a way for the LLMs to understand this.
on
Okay,
both sides, suppliers and yeah, clients for sure.
got it.
Okay, so in the book, how do we do this? We build this class called the MCP tool provider. It has the job of maintaining, spinning up and maintaining MCP clients, one for each server. And one important thing that I want to talk about for MCP tools, supporting MCP tools, is the first step is you have to know what tools exist on the server, right? So you spin up an MCP tool provider, it creates an MCP client, it establishes a connection to the server. The first thing you want to do is discover what tools are available, right? So it'll throw down a query. It'll be like, okay, what tools you got? And then, it'll send back the available tools. And in our framework, what we do is we take the discovered tools and we will build out what's called the MCP tool class, objects of the MCP tool class. The MCP tool class is actually a subclass of the base tool class that we talked about at the beginning of chapter 2. So we've laid out the infrastructure for tools in chapter 2. We're benefiting from that infrastructure here when supporting the MCP tools. Okay, so once you've discovered these tools, then essentially you can plug them in as you've plugged tools in to your LLM agents before. So like, if I go into the definition of this LLM agent, sorry, real quick, finding it here, right? This tool here was not an MCP tool, but another type of tool that we build where the execution happens here on this machine. Um, and you just pass it here. All I'm saying is after doing the MCP tool provider and discovering the tools, you can simply just do, MCP tool 1, MCP tool 2, right? Something like that. So you could do it manually. We added some extra convenience in the book. So I've added some extra convenience in a class called LLM Agent Builder that allows you to do that and build an LLM agent with MCP tools and servers more conveniently. Okay, so let's see this in quick action. So what we're gonna do here is I've built an MCP server. Um, I throughout the book, hopefully, hopefully people and my readers don't get pissed off with me or annoyed with me. I make use of the same example and over again, and that's intentional because I'd rather us focus on the stuff that we're learning versus the stuff that like the example, so like the cognitive load can be focused. And so what I've built here is an MCP server that will perform the Hailstone step function. So we built, this tool using the base tool class manually, using the simple function tool before, using the pedantic function tool as well. And now we're giving it another incarnate implementation via the MCP tool. Again, hopefully just to reduce the cognitive load and help you focus on the MCP stuff. So I built this MCP server. You can check out the code to the person who asked me the question. It's there. It's very primitive in terms of building out an MCP server. Nevertheless, it's there. When I execute this, what will happen is it's going to spin up a session because it's running the standard IO version, and it's going to communicate with that MCP server that's running. So if I now do tool discovery, which is this bit here, right? We'll see what tools are available. There's one tool that's available. Let's see what, the name, description, and these are all conforming to the base tool subclass that we talked about before. It's MCP Hailstone step function, right? Performs a single step of the Hailstone sequence. It's exactly the same parameter that the previous definition required. So that's tool discovery. And just real quick, I think this is the closing note potentially, or getting close to it. Supporting MCP, like tool calling with MCP tool. It's very similar, right? So we saw this diagram before. The LLM is going to select a tool. It's going to get back with a JSON that says, I want to use this tool, right? And then we have to actually perform the tool execution and then return the tool call result back to the LLM for synthesis and response, right? The only difference, the only specialization here is that we are forwarding that tool call request to the MCP server for tool execution. And when that gets back, we'll bundle it up into a tool call result because that's what our framework requires, and we'll send it back to the LLM. That's all the differences. Essentially, the tool calling is the same. Hopefully that makes sense, and let's see it in action. So we'll create a tool call, right? So this will say, okay, perform the hailstone on 16. Oh, sorry, this is not that. Oh, no, sorry, it is that. It just happened so quick. So this is the tool. This is an MCP tool, right? So if I go here, this is an MCP tool, right? And I'm passing it this tool call, which I provided. I just didn't go through the LLM route. This is me saying, hey, I want to perform a tool call and pass it to the MCP server. And this has actually happened externally to this application, but on that MCP server that just got spun up. Okay, that was a mouthful. That's an example of MCP tool calling. Real quick, this is just a real world application of the MCP tools. I mentioned GitHub uses or exposes a bunch of MCP tools, and what I want to show you are all the tools that it exposes, but I need to get my GitHub personal access token. If I do this, right, there it is. And here, this one is of the second type of MCP server. This is a streamable HTTP. This is what GitHub supports and exposes. And what I want to do now is I want to list out all the tools that's available. So you can see there's just a ton of tools. Create pull request, delete file, get commit, get label, get tag, etc. And I'll run this real quick. This is a task saying, hey, get me the latest release of the LLM agents from scratch repo owned by myself, Nerd AI. And while that's running, we will look at the next slide, which is skills. But actually, maybe I should just wait. No, not yet. Okay, I think it's running. Oh yeah, it's running. Okay, there it is. So it executed the tool call with this tool, MCP get latest release. Successful tool call, gave all that information. Then you should see a checkered flag. That finishes the task. So that's how you use an MCP tool provided by a third party. And this is what I mean by MCP tools. If you provide, if you can build out an LLM agent that can conform to that standard, then you can tap into all these tools. So like we as developers don't have to build out all these tools ourselves. All right. Real quick, next is skills. So this is a chapter that's in flight right now. I'm about 22 pages in. Once I get to around 30 pages, that'll be it, and then we'll get it into the editor's hands, and then hopefully into MEAP a few weeks after that. So in this section, we'll discuss what are skills, talk about the agent skills standard, which is you can kind of view it as similar as like an MCP thing. It provides a standard in which we could define skills and utilize skills, okay? And then we'll talk quickly about supporting skills in our framework. Okay, so what are skills? So we talked about tools. Tools are like these functions that LLMs can use that give them extended capabilities, right? Well, skills are documented like are procedural workflows. They're things that are like almost recipes. They are instructions that require specific instructions that you give to an LLM to perform a specific task that you define once and you get to reuse over and over. Okay, and those instructions can stipulate, say, like something like use this tool, right? So that's the difference between skills and tools. Tools are just like functionalities that you give to LLM agent, whereas skills are workflows. The analogy that I've heard that I think resonates with me, maybe with others as well here, is like it's a handbook. It's an employee handbook of how to perform certain routines. Okay, so that's what skills are. What is agent skills standard? Really cool that Anthropic actually did this too. So Anthropic introduced the MCP. Anthropic also introduced the skills and now made it into the open standard. And it's now adopted by Cloud Code, of course, GitHub Copilot, Gemini, Cursor, Codex as well. So skills is similar to MCP in that if you define skills according to the standard, then these clients and different agents should be able to make use of them if they do support these cross-client skills, which is becoming more of the norm. Okay, skills, how do you represent skills, these workflows? You define them in this skill.md file. And we'll talk quickly about in the next slide what's in that file. But I just want to make, again, a note that it is a growing ecosystem of shareable skills in marketplaces. These things are spinning up like crazy. And you might be hearing folks saying like, oh, I've built and deployed a new skill. So it's a really trendy topic these days. All right, and supporting skills, similar to MCP, we need to build out all this infrastructure. There's a skill scope, there's a skill class. It becomes a first-class citizen for the framework. There's a discover skills framework method. So in discovering skills, what we need to do is we need to write the code for the agent to scan certain skill directories according to various scopes, and it will find skills, right? That you've say you've were like, hey, I'm always asking my agent to add an item to my reading book list. And when I wanted to do that, I wanted to do some sort of summarization, give it a score, right? And you don't want to prompt that over and over again. So what you might do is actually encapsulate that as a skill, write a skill MD file, put it in a skill directory, and your agents should be able to scan that directory and find that skill. I'm going real quick because I know that we've covered a lot. So I just want to finish because I'm probably hitting the maximum capacity for folks here. But so let me just quickly demo. I've got a skill that I've baked into here, and you probably guess what that skill does. It computes the hailstone sequence using the hailstone tool. Again, just focusing on the components that you need to learn the new thing. So if you're looking at this, this is printing out what's involved in a skill MD file. So it needs a name, description, and then this is what we actually pass to the LLM for knowing that a skill exists and knowing that you should use it. And then maybe what I'll do is just show it is executing, and then I think we'll just one last slide on A2A, and then we'll call it. Daniel, how's that sound? Okay. Okay, so let me skip through that. Skill execution, real quick on this. So skills, again, are documented procedural workflows. Basically what happens is when an agent decides it needs to use one of those workflows, you need to give it the instructions of that workflow. Once it's loaded into context, then basically it's up to the LLM agent to perform that. So that's what we call executing the skill. And then, I'll just run this skill. So this is another method that we'll implement in the book. This allows us to run a task with a specific skill. I'm telling it to run this task with this skill here, and then you can see the result. Okay, last slide, I promise, and then I'm done. Thank you for bearing with me. We covered, chapters 1 through 6, plus a little bit about of the capstone chapter as well. So basically 7 chapters in this talk so far. So thank you for bearing with me. Looking ahead to chapter 9, the final chapter of the book, what we'll do is we will support another protocol called A2A, agent to agent. This was not developed by Anthropic, but Google. And to support that, again, we'll have to create some infrastructure in our framework. We'll do that from scratch. And what this will allow us to do is will allow us to expose our agents as servers as well as clients at the same time, able to accept and delegate tasks to other agents that support A2A and the transport there is HTTPS plus JSON RPC. That was a lot. Hopefully I didn't scare folks too much. But yeah, that was all I've got planned. Thank you so much for having me.
Thank you for visiting us. Lovely. So Q&A can start. So there was a question here, which LLM do you prefer? That's the one captured my eye, but maybe John can find some good ones. Can you hear me okay?
I can hear you. Sorry, were you asking me to get to the
Yeah,
chat?
yeah. So yeah, Q&A begins now. So guys, you can start either typing questions or opening the mics or raising hand. That's a good idea. So Ray, like I see your hand, and Samuel is, oh, this is good. So there was one question in here. Somebody asked you which LLM is your favorite. So like, which ones do you use beside Palantir?
That's a great question. I like that one. That's a hard question to answer. I perfectly like in open source, I've not tested yet Gemma 4. I really had good experience with QN models. I've tested out Llama, of course, and some other ones, but Quen Coder, um, when trying to cook up examples in the book that actually work with open source models because they're not, especially smaller ones, they're not as performant as the closed source ones, it gets a little bit hard. So QN3 Coder has been my favorite so far in open source. In terms of closed source, I'm very much a fan of Opus 4.6, 4.5, and Sonnet 4.6. When I'm coding nowadays or creating tickets, I'm using Claude Code with Sonnet 4.6.
Nice. So thank you. So I think Samuel was the first one. Let's go. I see 5 hands raised. Samuel, you go first, and then Ray, and we'll see.
Yeah, thank you. I was wondering, regarding when you're doing these AI agentic setups, I mean, right now you're using RunPod. What is your setup like? Which are you using the just GPU service or are you using their what are you using? How's your configuration? So as in like if I were to want to start, trying different models in open source and do some even I know it's a bit extended, but even want to train my models, what is the setup you recommend?
Yeah, I'm a big fan of RunPod. Like especially on training models, it's easy to spin up templates. Create a Docker image, yeah, and then spin up a template with RunPod. This is basically what I've done here. Um, Base 10 is also another option for inference. They also do fine tuning, and in fact, in where we work, we're using Base 10 a lot. And I think maybe on my local setup, I've got a mini server at home. It's not impressive. It's like two P100s, which is super like outdated. But it allows me to use like just Olama like 8B type of QN 8B models. Um, and at least for the book, for me, I'm spinning up just toyish examples, and so I'm not doing anything heavy duty. So that suffices. If it is something heavy duty, then I'll go into RunPod.
Thank you.
No worries.
My question was, did you build all the capstones using Olama? If not, is it because of the LLM's limitations or for some other reason?
Yeah, I think for me, I was wanting to build with open source models. Again, I'm a big fan of open source, and I think the what I was trying to get to is not have to use an API key to perform the task. So that's why I went down the Olama route. Though for the capstone problem, um, you know, if you want to perform these tasks at a decent speed and a decent performance, then you'll need to spin up bigger models, which is why we went down the RunPod path. I did also integrate or build an integration for OpenAI that quasi works. It doesn't yet support, I think, fully the responses API, but it allowed me to get with a valid, obviously valid OpenAI API key. I was able to test, I think, GPT-5 Mini on the capstone problem. So it is something that we can use, at least OpenAI. And I'm definitely open to folks in this community or elsewhere to, submit PRs for integrations into Anthropic or Google, etc.
Nice. Abdullah, you go next.
Yeah, thank you. Got really curious about the MCP servers and how they work under the hood. And I'm just curious, what protocols does MCP servers use to execute functions remotely?
In terms of the protocol?
Yeah,
Or
like how agents communicate with MCP servers to execute functions remotely.
So maybe this answers your question. If not, I apologize.
All right.
So the LLM agent will do is it will, similar to the tool calling procedure that I laid out before, is like it will select a tool. Perhaps it's selected an MCP tool, right?
Mm-hmm.
And what it will do is it will look at the requirements for that tool, like the parameters JSON schema, which then gives it the information to like, oh, I need to provide these parameters. So like this tool call, it's a data container that contains the tool name as well as the arguments for that tool. Right?
Okay.
So if it's selected an MCP tool, that's going to get passed to this MCP tool abstraction that we build in the book. And then this bears the responsibility of forwarding that tool call, reshaping it into the format that's required for MCP servers, and forwarding it over to the MCP server. And then the tool execution happens that way. But it's basically the same type of payload, tool name and a JSON schema of the parameters. It's just that, if you use MCP library, you got to conform to their data structure for it, right? So that translation is happening here. And then we just forward it to the MCP server, that execution happens, and the result comes back. Again, that's an MCP primitive. And so we need to, reshape that into the framework's tool call result. Does that answer your question?
Yeah, interesting. So basically, we're using JSON to simplify the communication between the two.
Yeah, exactly. I think it's based I'm going to write some appendix on it, but I'm a little bit fuzzy. I think it's JSON RPC 2.0. If that makes sense.
Yeah.
I think so. So before the next question, I promised a free book for your book, coupons before the end of the meetup. So we'll stay longer for Q&A, but I'm pasting right now 5 coupons. So whoever's faster to grab one, good luck. For the rest of you, use Toronto 24 coupon. It's still active for 45% off. So good luck posting now. And the next question, Joe, you want to go?
Hello, great presentation. What do you think is the most needed? What do you think is the most needed next development for AI? What do we need to build?
I think security and regulation. I definitely think along those lines. I think, a lot of the stuff that's being built right now, and LlamaIndex was definitely a player in this, is a contributor to this, is like engineering the crap of like getting these things to perform tasks. And to me, like, security, safety, and those things are often an afterthought, I feel. And I feel it's like that's also what's happening here. So yeah, something along those lines of safety, regulation.
Thanks. By safety, do you mean reduced hallucinations or something else?
Reduce hallucinations, but other harms, right? So there's like biases in the model in terms of of how it's trained. I think the theme of that is like making sure folks, like AI is meant to help everybody, right? And there are biases in the data that it's being trained on that will prevent it from helping folks equally. So those kind of things, as well as like
my headphones died.
Like privacy and security are also concerned. Deepfake is a risk as well these days too, right?
Do you think Yan LeCun is right that we need a new architecture?
Yeah, that's an interesting one. So like he's talking about world models, right? So LLMs, we touched on this before, are predicting the next token based on the sequence of input tokens. And so people have, called these things as pattern matching, right? Finding the statistical patterns, correlations, if you will, but they don't know the causality of, why why we should take this token or this state. So what Yann LeCun is proposing is something called a world model, which understands causation of these input. They're not tokens that you're dealing with, and I might be butchering this, so I apologize if you guys are
I
experts in
think
this.
so.
But yeah, they'll look at the states. So it's a sequence of states, and what you're trying to get the world model to do is to predict the next state, but do so in a way that it understands causation. And his thinking of that is like using videos for training. Yeah, one last thing on the world models. I think Jensen Huang of NVIDIA said physical AI, so robotics, are about to hit their ChatGPT moment.
Thanks.
Thank you. OT, I think you're next, huh? Okay, OT is not there. Chaitanya?
Hey, yeah. The question is, right, so both MCP and A2A are for agents communication, right? Like which way is the industry is moving more towards A2A or MCP?
Sorry, is your question of like where is the industry moving towards?
Yeah, because MCP and A2A both are used to talk to agents, right?
Yeah, that's an interesting. So like you're saying like we can expose an agent as a tool and then just use MCP tool. Is that what you're saying versus like an A2A type of thing?
No, so we use MCP to talk to different agents, right? Because the client and so what is the difference between MCP and A2A?
So MCP is based. So on MCP, what that is exposing for the agent is a set of tools. I mentioned there are other primitives like data and prompt templates, but predominantly it's a tool, right? So web search, code interpreter, that is being made available on the server. If you're looking at GitHub, it's like create a pull request, um, get the latest release, right? So those are all
Mhm.
tools that sit with their server. That's not an agent, right? So
Okay,
like those are tools. In A2A, what you got is on the other side of each of the communication lines are agents, and they are sending tasks to one another, delegating things to one another, planning and communicating in that fashion to build a multi-agent system.
got it. Okay, cool. Thank you.
No worries.
And I think Christopher, you had hand raised. Christopher Kruszel.
Yes, thank you. What is your opinion that CLI is more effective of a tool to use rather than calling MCPs, more efficient in token usage?
That's a great question. Maybe it's one of the things I should do an analysis of. I don't know if I have a good, strong opinion on it, though I do think that CLI is can seem a bit easier. Um, where I've ran into this is that, like for example, if my work doesn't support the GitHub MCP, then as long as I'm authenticated on GH, then I'm good to go. But it's a great question. I don't really have a strong opinion yet, but maybe that's something that I will form one through getting a capstone project, excuse me, on. I would be curious to hear if you've got an opinion though.
I've been hearing about it. I've been seeing that MCP is dead. MCP is outdated now, and that CLI is the next thing with installed tools or installed applications that you already have on your system, or that are part of the harness. Whereas MCP is kind of legacy and more for like more legacy applications. Yes,
Yeah.
I see that someone commented CLI is basically an MCP, but I could also argue that CLI is just calling the native application itself and then sending the information back.
It's
Yeah.
hard to judge. It's a spectrum of options. So I prefer using GH command line tool rather than GitHub plugin. It's faster for me, but there are different use cases, so it depends.
Yeah, on one use case, actually, I was trying, and maybe it was just a bad day for the model, but like when I was trying to build a skill for adding some item that I wanted to read later on, and I was trying to get to use DH, or maybe it was GraphQL, to add, yeah, it was GraphQL, uh, to add items to a discussion board on my GitHub project. It was struggling, like it was not able to do it. And then it wasn't until I built my own MCP tool to do this actually in Python. So it's a little bit different, but that tool helps stabilize that use case. So maybe there's something to be said on that as well.
Yeah. So we have next Christopher with C. You raised hand quite a lot.
Yeah, so I would just quickly weigh on a question about the MCP. The thing is with the MCP versus the CLI, you end up it can lead you into putting your credentials into the same context that the agent can kind of inspect. With the MCP, what you have is like a partitioning where the client communicating with the server has the credentials, the client just allows permission and commands to flow over it. So if you're, agent isolation is a big thing because you want to run your agent in an unrestricted manner, but at the same time, you want to give it access to tools. So, so that's one use case. But I want to ask a question though.
Great.
So this whole thing with the frontier models versus getting the open source models. So to me, what I see is the frontier models being used to sort of prototype, make sure you're getting things working. Once you've figured out what you actually want, you go get an open source tool, open source version that has similar capabilities. But what I was wondering is how would you assess whether or not the open source one is actually giving you an equivalent thing. Now, obviously, if you have a specific use case, like, hey, calculate X, then you just ask the open source one, calculate X. So obviously they're equivalent, but that's obviously not exhaustive, right? So I was just wondering, like, I guess that leads into evaluation. Maybe, I don't know. What would you suggest to kind of figure out that the two models are giving you equivalent behavior, or at least covering the use cases that you know?
Yeah, for sure. Firstly, thanks for your comments on the CLI versus MCP. I think that was a great perspective to add in there. In terms of the open source versus closed source, I agree with your strategy. It's a strategy I, propose as well, like to use these strong generalist models, if you will, that can perform a good baseline on your task. And then if it's something that you need to repeatedly do and you want to, be a little bit more unconstrained in terms of rate limits and also reduce costs, then you may turn to open source models and fine tuning, right? In terms of how you would know, for me, the answer is always evals. Like, I think actually before you start any LLM application, you got to have a good eval rig, right? So, and that affords you so much, right? Not only like open source versus closed source, but like, hey, when ChatGPT or GPT-7 comes out or Sonnet, 8 comes out, like you're able to test if these model updates are worth you upgrading your application for. And just to maybe just like give that more some concrete, like, we've performed LLM extraction, and for extraction you can get that a good like baseline benchmark, right? So you can get humans. I'm a big fan of humans still verifying, or at least annotating, or at least verifying the ground truth data. If you've got that and you've got your benchmark, you've got your right metrics. In the case of LLM extractions, it's maybe precision, recall, accuracy, right? Once you've got that harness built, then you can easily compare, right? Frontier, closed, and open models.
Can you suggest maybe or provide some links about these evals? I really don't know anything about them.
Oh, sure. I don't know if there's evals on these ones, but I can provide some links if you connect with me on LinkedIn to benchmarks that, are at least ones that we're inspired from.
Sure, you can use Ragas or
Yeah,
Prompt
Ragas
or
Is your LinkedIn in the chat?
I can give it, oops, sorry. I don't know. Go to profile, right? And
just fumbling with the same thing.
We just go here and there you go. Yeah, we can continue the discussion. But Ragus is like, there's other eval frameworks. Ragus is one. I think Arise has an agent eval harness as well.
Yes.
LlamaIndex actually came up with their own eval on parsing called ParseBench. But the theme is like, yeah, make sure you have proper evals before. I would argue like you don't spin up any AI application without understanding how you're going to measure success.
It's a first-class citizen. It's no longer like testing afterthought. And the comment, I think, Chris, you were asking about swapping the models. Like, it's not easy exercise at all. Like, I thought like Gemini, similar family models, but it's wasted time. Like different people, Gemini 2.5 Pro versus Gemini Flash 3.1 versus Gemini Pro Preview. It's just so finicky. So without evals, you cannot move. And that's why I think rather than you swapping the models, focus on the one that will do the job if you can pay for it, and then maybe become price aware. But it's another beast when you have to host models yourself. I would swap for cheaper models. I've seen lots of providers getting results quickly, like vendors getting results quickly with the smartest model, and then optimizing maybe Gemini and Flash, like depending on the use case. Each of them has different qualities. For instance, Gemini is good as finding needle in the haystack, or multimodal analysis. I'm now transcribing videos, capturing what's behind on the screen. That's why I play with them. So it depends on the use case. It's hard to generalize and try kind of not to move too much. It's going to be really wasting of time, and business will be waiting for result, or whoever promised to do something. I feel like a plumber, like I think I'm going to replace the pipe, and then you find mold in the wall and spend next 2 days ripping just because the new model was not the same. And I do have evals, but you get surprised. And there was something that, I know we are over time, so I understand if you have to go, people. But there was something important, two important facts throughout the theme of the meetup. And I understand you overloaded with info. But you can see, even in the title of the book, the skills are not mentioned. When I met Andrei, when was it, December, January, we were not even talking about the skills. But industry is moving so fast, and then so people are jumping on the skills. So what you observe through this meetup and through working with early access book writers like Andrei, you can learn what's coming, not what just happened. So lots of book is what happened. And then skill section did not happen yet. Like it's happening end of March, like most of the big players adopted agentskills.io. That's the website where Anthropic is donated. It's still not foundation, but it's there. And why I like it. So for instance, if you have to deploy, this is my opinion, Andrei, please criticize me. So as a consultant, I come into companies to help them introduce agentic AI. And there are two phases there. There is a business knowledge that's in the heads of non-technical people who do the work. And they codify their knowledge through plain English, which becomes markdown, which becomes text. That's part of the skill. And then we take care of the deterministic part, those Python scripts, those MCPs, tool calls. So there is a bigger benefit to skill itself. It helps businesses and IT work together. We are no longer passing requirements from them to us and then validating requirements. It's like tag team. We focus on the infrastructure, security, scalability, tools, and they dump their knowledge into the text. And this is so big, like that Microsoft, they just announced it at the end of March. They licensed Cowork from Claude. So Copilot is getting Cowork in there. It's in frontier model right now. So watch where industry is going, and do not just jump on the tools, jump on like what's easy for business users, which is Cowork and these skills. So that's my learning from last month on a new contract.
That's awesome. That's cool.
Any comments, questions? Everybody's so quiet. We can stop if you want. Any other questions?
Yeah.
I see Marcus hand right there. Go ahead.
Yes, I had my hands up. So yeah, thank you, Daniel, for that very
nice comment at the end there. I think that makes so much sense. Skills. Andre, just a question for you. Nice presentation. Thank you for the presentation. Throughout the presentation, I followed all through, but I was just wondering what your storage or persistent storage solution looks like. Because sometimes, we want to give these agents persistent memory. Say I want to give it a recurring task, say maybe quarterly reports and whatnot, and I want it to have previous context that it has worked with. So how are you managing that? Or I don't know if I missed something during your presentation. Thank you.
Yeah, no worries. Thank you for the question. It's something that I haven't yet solidified for the book. That will be the next chapter. You're talking about memory, right?
Yes, exactly.
Maintaining sessions.
Yeah.
Yeah.
I know that's one of the hardest aspects of agentic AI.
Yes, exactly. This is a big component of agents, and one would even argue that it could be part of the canonical definition, though I decided to leave it in later chapters. I'm not yet 100% sure. I think I will use a couple of options. A simple key value store, I guess, is one thing. And then there was a thing that we used in LlamaIndex and other folks are using in terms of vector-based memory. So that's an approach. The other thing I might be thinking in terms of including into the book, though I'm not yet, again, convinced as to what approach I'll take, is I think there's graph databases that we can maybe use. And then also, I think Andre Karpathy came up with something called a wiki. So all these things I think can be massaged into a version of a memory that then will need some certain correct infrastructure then to implement. But yeah, I think I've just not done the heavy thinking as to how to do that in the book. That will allow the readers to know what's out there, but also learn it in a way that is complementary to what's being already written in the book, if that makes sense.
Yeah, I think that makes sense. I've been experimenting a lot with the graph RAG aspect. It's working well. Just one thing I'm concerned about is the scalability of it. So I've had, say, for example, I don't know, a couple of hundred agents, but when it comes to over 1,000 and all of that, I'm having issues with keeping the system stable and whatnot. So I'm just wondering if anyone out there, on this call is messing with that kind of stuff. It would be nice to maybe share there. I'm happy to share my LinkedIn and we can maybe work together on that.
That would be great. Please do include me too, because then I can, take those notes and see if it makes sense to put into the book.
Yeah, for sure. Thank you.
Thanks for the question.
Mark, you have your hand raised.
Yeah, I was I had heard of another protocol, ACP, and just a few days ago, Claude informed me that ACP was rolled up into A2A under the Linux Foundation, and I was wondering why was that the case, and what's the benefits, and how does that affect the sort of why? Because if they're two separate things, they're two different whys. But now if they're combined, then how does that affect your choice and why you use A2A? I don't know.
I actually did
That
not
makes sense.
News. Sorry, go ahead.
That's it. I'm done. I was just wondering.
My research on ACP is quite limited, and it was fairly recent when, again, similar to what Daniel was talking about, the space is moving. When we first laid out the book, I don't think ACP was there, unless we just didn't do our good research yet. And then it was just till later on, the editor's like, "What do you think about ACP?" I was like, what are we talking about? Anyway, in short, I don't know the answer to your question. If ACP did get bubbled up into A2A, then I think it's just like we, maybe the industry is like feeling we got to converge on these protocols. Yeah, I'm not sure that if anyone here can answer that. I don't know if Daniel, you've looked into A2A and ACP.
No, I haven't used either of the two. So my problem is like what I observe in the companies, like we developers like to build frameworks, and this is not new to AI. Like every company, big one, has center of excellence. They dictate how it should be done, and then you push it on the poor developers without properly finished framework. So I think like skills are solution to those in-house frameworks, or like we are not talking in-house, but the fact that developers lead with frameworks is not easy for business to adopt. And that's why I'm so excited about skills and mixing plain English into it. So I think it's going to survive, like win.
Yeah,
But I
skills
don't
felt
know.
like it's something that was very important, which is why I was like, I think it'll be a miss if it's not in this book. I've sort of been hoping that A2A still is relevant, and when I get to that chapter in chapter 9, I've been sort of being narrow focused per chapter.
Probably it's going to stay relevant because Google's behind that, and they have payment protocol. This is A2P. They have UX protocol. So these are building blocks for agents without people. I'm focused on people, like codifying knowledge of people. So that's my hobby and interest, to help businesses automate themselves. So I may be biased, but I think it's not dying A2A. But the other one, I don't know. It's good branding for IBM.
Great. I like hearing that because that's still in the plans. I think Isaiah has a question.
Hello, can you hear me?
Yep.
Yeah, the question I had, we're giving a whole high-level overview of multi-agents. I've been experimenting with doing that. I'm starting with a simple worker to reviewer pattern. And you hadn't really touched on like roles or what kind of sub-agents should really be performing as when you're developing this system. Then I also found a resource like ARXIV. I'm just kind of curious if there's like scientific ways to empirically measure, agent performance, what they should be doing in life cycles, that kind of stuff.
Yeah. I want to say that it's sort of something that we're still fleshing out as a industry, in my opinion. Like, I've got colleagues that are spinning out sub agents for doing a lot of coding, complex coding, not even just coding, but like complex, like heavy like research-y, sciencey type of problems. And the agents will delegate amongst themselves to do that. I don't think we have any opinions in terms of, at least right now, on how to structure those patterns, and maybe others do, but at least in the company and my coworkers, that's not something that we've landed upon yet, outside of just using default settings. However, like we will say that, they're not only this company, but like people are seeing success with it. But then, I've seen a paper that is being recently shared and is out on archive that says a single LLM agent is outperforming multi-agent systems, actually specifically using A2A as well. So I think it's still early, to be honest. I think eventually, for very complex tasks, I believe multi-agent systems and multi-agent interactions, at least that's what this book is also banking a bet on, is that it'll become more and more relevant. I just think we haven't been able to harness the true power of it just yet. Hopefully that adds some useful commentary.
Oh, any other questions? We're close to 8.
I have one. When I start working with new developers, the first thing they want to know is, why do we need another protocol? Since we already have things like REST API and GraphQL, why do I have to use things like A2A and MCP?
Yeah, that's a good question. I'm not sure if I know the answer to that. I think that I sort of feel the pain a little bit too of just trying to support new frameworks. But how do those discussions go with you and your coworkers?
Well, I think that nobody has a really clear answer right now, but to me, the things like REST API and GraphQL aren't customized for agent to agent or agent to tool interactions. So like GraphQL can go out and collect, but it doesn't really do that much discovery. So you have to start adding things like discovery and introspection, and calling more than one resource, or it's dynamically configured, or it's not known until runtime. But I'm not the expert; otherwise, I wouldn't have asked it.
No, I'm not sure if I am in the position to answer that question, or maybe at this time.
Yeah, at a certain point, you just say, "Well, that's what everyone's using." Like the big giants are all
That's
moving
basically it.
towards that. So we have to use them. Another question I had is if you have an IDE you prefer, because there's all this activity between things like Cursor, Windsurf, VS Code, anti-gravity. Do you have a
Yeah.
preference?
Thanks for this question. This one I can definitely opine on. I tested, so I was always a VS Code guy, right? And I had my settings and stuff like that, and I was not using coding tools. Like I was not using it integrated into my IDE for some time. I think I only started doing it in January. I've been using LLMs, but I would just like copy and paste code and ask like, hey, is this, good standard? Is this like, asking its thoughts on that. But then I was like, okay, in January, I was like, I better start using, some of these tools. They seem like, people are getting a lot of success with it. And so I tested Cursor. And, I was moving from VS Code to Cursor. I personally don't like the auto tab complete. And I don't know if it's just me. I just found it annoying for me, so I had to turn it off. But anyways, I kind of didn't feel very good in that. I don't know why. I just didn't feel as nice as what I was working with in VS Code. And then, uh, the Claude Code, I learned of the Claude Code extension with VS Code. And I was like, oh, let me try that. And now, I'm using that like only. Like I'm back to my VS Code using Claude Code, and I'm loving it so far.
Okay, that answers my question. That helps a lot. Thank you.
No worries. Thanks for your questions.
This is good. So that's another thread, simplicity. Any other questions? John is still at work. He'll have to go home unexpectedly later.
That's a lot of information, but it was a great crowd today, and we had all sorts of questions and discussions. No, it was a fantastic session.
To be continued, like in
Yep.
this forum or others. And thank you for all the ideas for the upcoming meetups. Andre, you contributed a few
Yeah,
as
there's
well.
some good ideas there. I agree.
Yeah, I mean, Sebastian would be great. He's amazing. He's the GOAT in terms of Manning book. So
Tell them they don't know, like it's our chat one-on-one. Tell them
will
we
do.
recommend it.
Oh, yeah.
No. Yeah.
Oh, tell the crowd right now?
Yeah, they don't know. That was a private chat when I asked you who to invite next.
Oh, sorry, I'm confused.
So the next money goes Sebastian, the authors.
Yes. So he's coming to give a talk here?
No, give them the context. Like I was asking in the chat while you were presenting who to invite next.
Oh.
Same question I asked you.
And then
but they don't have the context. So
okay, I'm with you
can
now. Sorry, I
repeat.
took some time there.
I'm sorry. I jumped the
No,
context.
it's me. My
Poor context
my PM
management.
brain.
I apologize, me.
Well, this was awesome. Thanks, guys, for having me. Like it was like again the first 15 minutes. It seemed so cool to like have. I've never seen so many people like want to introduce themselves. That was awesome.
From the old days when we had pizzas.
Yeah,
and
we
could
used to get
handshake
it. We used to get together in an office and have pizza and drinks and chat and go around and shake people's hands. And you can't do that after COVID hit. So we just started doing the virtual introductions. Yeah.
Oh, I see. Yeah, COVID is a bummer.
But it helped us get remote work.
Yes.
It's really like it's so nice sit at home, like my dentist like chair. 12-hour shift. AI is not helping me work less.
No, if anything more, right? It's like, oh, I can build this thing in like a week. I should just do it.
So that's cool. So guys, like we can wrap it up if you want, if there are any other questions unanswered. Go ahead.
Hey, this is Chris. I want to say one more thing. Hey, there's somebody that was hijacking the meetup and kept sending that scam thing in there. I don't know if you saw that.
Oh,
No.
you're talking about in the chat with Meetup, yeah.
Yeah.
You gotta ignore that. I don't know if there's anything we can do about that.
They were really determined. They sent it in like at least 5 7 times. They kept saying that
Yeah.
their daughter died and they wanted to give away a laptop. It was so ridiculous.
That's the meetup. That's the meetup site. I'm not sure if there's any way to fish that out, but yeah.
I did not even see that.
You tune them out after a while.
Hey,
Great.
guys,
Go
it
ahead.
would be fantastic to do this every week for a kind of AI study club just to keep up.
I cannot commit to the time. Like it gets exhausting to organize meetup, and even Andre, we worked 2 months on this one. So
You did all the heavy lifting. I'm just
no, you wrote the book. Come on, I'm just listening. I'm the movie critic, and I'm movie director, and you are the star.
Oh man.
Anybody else, or we are wrapping this up?
Scanning the
Good.
Okay. Final thoughts. I will stop the recording then.
Yep.
And then share it in a couple days if the time allows. Thank you so much for doing this here. And so we'll see what to do next month, but so many changes in the IT industry, so it's hard to predict what's important. But the basic core principles, we cover them in the meetups here. So because there is lots of new folks, it's systems thinking, design thinking, and business analysis. Not as analysis itself, but understanding business needs. So we are shifting towards the left. And then regardless of the problem they throw at you, you're going to be like Cat. Be able to understand it if you apply systems thinking principles and design thinking. So that's my advice to anybody new here. Go through a playlist and then read his book. Manning, like I'm not promoting that them. I'm not paid for that, but they have a good balance of the price and the quality of the books, and they're trying to solve the same problem, how to stay relevant, and we are trying to solve the same problem. So that's why if you kind of pull our minds together, there's going to be more value for you. So.
Great advice.
Yeah. Okay. Have a good night, everybody. I'm gonna fly.
Okay. Thanks
Yep.
again,
Yeah.
Daniel. Thanks again,
All right.
John. Take care.
Thank you, Andre. Bye. Enjoy the Boston run.
Thank you so much.
Bye-bye.
See ya.